15 minutes left. Will you speak it in English or just listening? Okay. So, I'll just turn on again this one.
Welcome for the announcement of this year's Nobel Prize. Has today decided to award the Nobel Prize in Physiology or Medicine jointly to
has this morning decided to award the Nobel Prize in Physics to has decided to award the Nobel Prize in Chemistry in equal shares to
The Nobel Prize in Literature is awarded to
has decided to award the Nobel Peace Prize to
award Sveriges Riksbankspris in Economic Sciences in memory of Alfred Nobel to
After 30 minutes starting the live. And I remember maybe that was 7 or 8 p.m. last year, but you want to make like ASMR rather than speaking something. So I will explain the Nobel Prize in Physics in every year. You know who received in the last year?
혜성 Lee,
No. I mean,
예찬 Kim,
no.
본명 오케이.
Don't speak
오케이.
the
오케이.
real
네,
name
네.
in here. Yeah. You know the ChatGPT, AI, they receive. Who make the theory for the GPT? Machine learning and artificial neural network. 제프로이 힌터. No. In this book, he is 제프로이 힌터. Yeah, same guy.
너 안 닮았어.
Here, 제프로이 힌터. 제프로이 힌터. 제프로이
라운드.
round, but
너 라운드.
Yeah. so actually, in the previous year, I made the presentation like this in front of the student because I'm a teaching assistant now. And yes, in the final slide I make this one announcement of the 2024 Nobel Prize in Physics in the October 8th, and really they received the in topics of the AI. And two years ago, you know them? No one's know. They make the atomic clock. For example, that this is hour, millisecond, but they made the attosecond.
아토벌.
World does.
미스.
In the 2022, 3 years ago, maybe I used, yeah, this one. They make experiment for the entangled photon and the barrier inequality. You know the Schrödinger's cat. So if there is a one Schrödinger cat and the far away there are the other Schrödinger cat, and they are entangled whether they are alive or die.
하프.
Very sad. Yeah,
슈레딩거 bad boy.
yeah, here is Schrödinger.
Bad boy.
In the there is a physics, and I mean the prize in the physics and the chemistry and this medicine in the biology. You know the literature,
문학.
yeah, and the peace and economic science, and there are no old science,
올드.
old science, astronomy and the earth, and they received for the modeling of the earth climate. You know the climate, weather. So
기후.
because there's no old science, so they receive in the physics prize. Understand?
Yeah, Earth said. Earth
No old science.
scientist
Yeah,
said.
yeah. And 2020, this is Roger Penrose. You know the Stephen Hawking. He is a grandson of Stephen Hawking,
Old
and
man.
he's a mathematician. And I have the book.
His book.
Yeah, his book. You know that the road to reality.
로토디.
실체 이르는 길. He's a very old man. 2019, Peebles is also very famous man
Peebles.
for the cosmology.
2E.
He is Peebles.
Everybody white hair.
Yeah, maybe. White hair. No, he is black. Yeah, and the
영.
2018, some laser physics. 2017,
You busy ear.
yeah, I was busy at that time, and this person keeps on. You know the Interstellar movie? He made that. So this is they received the prize to the
자, 앉아서
gravitational
좀
wave.
들어.
No.
아이 마이 클로즈
Yeah,
체인지.
okay. You don't need to listen here. Okay. Bye.
Mom, listen Nobel Prize.
리슨 듣고 노벨 프라이즈 노벨상
You can understand what I'm saying here.
You can
Can you understand?
이해했냐고?
Yeah, what I'm saying here. So the remaining time is the 41 minute 8 seconds to start in the Nobel Prize. 41
41분
minutes.
남았대.
Yeah. And I explained the
뮤직스 피직스 노벨상 받는 거
yeah.
누가 받아?
So 40 minutes after we know, now we can know. Everyone don't know still.
아무도 몰라.
Yeah. Yeah.
후보자가 있을 거잖아.
So yeah, also there is a nomination. I can candidate.
캔디다이트 추천했다.
Yeah, Nobel Physics candidate.
후보다.
Yeah, candidate is 2025, but
선호하실 거는
that's still secret.
시크릿 비밀이다.
Yeah. So here is a process of nomination and selections, and
교수다.
we don't know the
봐봐.
candidate. No. I don't need to some specific listener here. I don't need.
아무도 안 필요하다.
Yeah.
오케이?
어제 노벨 의학상을 일본 사람이 받았대.
I don't have interest in the biology. Only physics.
그때까지 일본에는 노벨상이 28명이에요.
Because many basic science is well developed, even in the 100 years ago.
이모준 씨.
Kawa Hideki.
이모준 씨.
What happened?
Because of you, I thought by English my head.
Pardon? So why English make your head
I thought in my head by English
So also
by myself.
in your brain, you think yourself in the English, not Korean.
Yeah, not because of you.
That's a very good situation.
Emergency.
Emergency.
I'm becoming American.
This is Nobel Physics 2016. Saulas, this guy is a very old man.
Old man.
He, David Saulas.
Necktie color.
Yeah. They received by the topological solid physics. Yeah, and this man is very important. You know that this one. Neutrino relation.
McDonald's.
Neutrino mass. I don't mean the McDonald's. You know the neutrino.
Loteria rival.
So this also McDonald is a Canada guy who made the I don't know the experiment, but he's a Japanese.
Oh, Kajita.
Maybe the super kamyokan experiment. You know the neutrino.
Yeah.
You know, 2014. Some optics, and this is very long. Blah 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 blah. This sun Large Hadron Collider, which is the institute in the Swiss.
Nice.
Yeah,
You will go?
yeah. So he is a very also old man. He has a particle.
Hey,
He
돈 걸럭.
understand. Oh.
Napkin.
What happens in you? 2000, 2000.
Corona. COVID.
No, until COVID there are Nobel Prize. 2011. The discovery of the accelerating universe.
Absolutely.
You know the dark energy. So, what happens in Wi-Fi?
Oh,
Yeah,
이어폰 브로크.
again. This one,
Vacation.
dark
Schedule.
matter, dark and not vacation. This is a composition, percentages of the dark matter and dark energy.
Oh, I know this picture.
This one, these pictures.
I know.
So this is accelerating.
Pretty.
How much minutes left? 36. Should I button this one?
Yeah.
Okay. Good idea. CCD 남부 요이초 spontaneous matter breaking. Also, I have a book.
That
Hello. Maybe some interesting guy. Synthetic freedom and the strong interaction.
Oh wait, I have a question.
You
But
have a
Korean
question.
memo.
Gingerbread for superconductor. You will translate. Atomic, cosmic. Yeah. Very good time. Okay, yeah. I understand.
Yeah. So you should tell me.
How much is this
Yeah.
pen?
Our.
Oh, Gerald Topt. For the electro Topt.
Top.
This guy, I will
H는 부분.
turn on this guy and maybe
Mono picture.
maybe I can bounce some pictures here. Just a moment.
I don't see
In the why?
your personal information.
Not personal information. 2023, maybe.
Oh, I need to drink orange juice.
Where is he?
Wow, so many orange juice.
I can't find it.
That's okay.
Where is he? I had a picture with him. I can't find.
Sad.
Am I lost?
Difficult sentence. Am I lost?
I really lost.
Sad.
Oh, I find it. So why this guy, but why? And this is me. And why? The quality, the image quality is not good. Same guy.
Oh, you may guy.
Interesting. I can one more YouTube now.
So old.
Yeah, 1992. But because there's no time, we should pass past. You know the birth years of Nobel Prize in Physics is which year? The birth year. When it started?
1889.
Almost similar.
1887.
9001. So I can't do one more YouTube now.
English
English time.
difficult.
English difficult.
나 WG 보서.
여보 자기 English 하고 있잖아. difficult 하대.
Oh,
Help me.
my professor love him.
Oh, Wilson.
I don't need to burden him. Oh, what happened? Again, 2020.
You said
Yeah,
many times wasted.
2000.
English가 difficult 하대.
2000.
자기는 English 많이 했잖아.
Duolingo.
근데 저는 전문적인 거하고는
89, 88, 87, 86, 85, 84. So Wilson, my professor love him.
Why?
His idea is quite interesting. So his this one, Wilsonian renormalization group.
Wow, keyboard fast.
This is a Wilsonian renormalization group. So some number, like a coupling or mass, follows this line.
I think that is 환풍구.
Interesting. So still 30 minutes. What I do is this.
My
really-
nose 건져.
Oh, these guys are also very famous man.
Man.
Yeah, I will.
Yeah.
This guy. So Stephen Weinberg and Benjamin Lee. Benjamin?
Lee.
Yeah. This
Oh.
person looked like Korean,
Yeah.
very famous Korean. And he is, the Weinberg is his brand.
Run.
And if he alive in this time, then he can also receive the Nobel Prize. But he died
Sad.
because of the car accident.
car.
So Benjamin Lee died in the 1977.
So unfortunate.
Yeah, he's not. His age is the 43.
Young.
Yeah, very sad story. Oh, Penn-Johnson and Wilson discovery of the cosmic microwave background.
Again Wilson.
But the other Wilson, I think. You know the cosmic microwave. Yeah, that's a microwave.
Yeah.
So in the universe there are many microwaves
Oh, no pretty.
like that. So red mean the high temperatures and the blue mean the very cold temperatures. This is a very wonderful thing. Something and something. Thing, yeah. They discovered the heavy elemental particle shaped psi. Or maybe some people are in this room, but still not. Radio physics 70, still 73. What times minute left? 28. Light. Yeah, Bardeen, Cooper.
Oh, Cooper. I know Cooper.
Who is that? Shui Apple? I don't know the pronunciation.
Schrödinger.
Maybe this guy, John Bardeen. So, BCS theory for the superconductivity.
Soka.
Yeah, so this guy is very famous, Gell-Mann.
I know Gell-Mann.
You know Gell-Mann?
Gell-Mann.
Gell-Mann matrix. This is a Gell-Mann matrix.
Bad matrix.
Okay, Gell-Mann. You mean this?
Bad.
It's bad to you. Maybe the
No bad. Something bad. Sleep bad.
yeah. He made this. Oh. Who made this? Is this my pictures?
No.
Because also I make this picture.
Pretty good.
Yeah, just one.
Oh.
This is my home page. And I made this also.
Oh. Thumbnail is good.
Written in Korean.
Thumbnail. Oh.
Also I made this. Oh,
Very 입체적.
yeah. But also someone also make this. Yeah, anyway.
Pretty good.
Yeah, but test why the star make the energy.
I need a pizza.
You know the pizza.
Need.
You mean the real pizza or
Need.
cat pizza?
Cat pizza is real too.
You know the Weimar?
Feynman.
Yeah.
Feynman.
Here's a Weimar somewhere.
Feynman.
Here's a Weimar.
Lost.
I lost. Maybe somewhere.
Newton. Turn.
Here's Weimar.
Well, this?
Yeah. Making radio and spy. Such a people.
Sleep.
Yeah. Eugene Wegener. Landau, he's very genius.
Landau.
Russian guy.
Russian guy.
Still 60, yeah?
Not ski. Ski.
Yang Jianing, Li Jiangdao. Famous
Chinese?
Chinese. They discovered the CP violation.
CP.
Again, hear the John Bardeen again.
2 years.
You know the semiconductor? 반도체.
며칠 전에 했는데.
Yeah. Max Born, also very famous. Now the 52. Another when the Korean War started.
27.
No, 60. Yukawa Hideki is the first guy who receives the Physics Prize in the Japanese.
줄까요?
먹기 먹어야 되는데.
그 나물을 비벼 먹어요.
I'm not hungry.
Yeah,
나머지 밥
9 million left.
난 배 안 고파.
배가 고픈데도 아프다 배가.
약 먹어.
Pauli,
갤풍수 같은 약을 큰엄마 집에서 갖고 왔어야 되는데.
no Nobel Prize Physics
이런 것도 좀 먹어야
during
돼.
the
근데 한봉수 같은
World
거
War II.
아빠한테 받아와라 해야지.
던지라 할까 바깥으로.
아니.
You know the Schrödinger and Dirac.
5의 포인트.
Two that.
두 낫.
갤풍수 같은 약 있잖아.
And also
그거 한 통을 다
아니
먹어.
엄마 차키도 그 층에서 떨어뜨려서 머리 맞고 죽는다.
그래
그냥
그럼
떨어뜨리면 안 돼.
그또 차에 맞아갖고 차에 손상이 너무 안 된다.
you know this
나
episode.
전화기가 차에 있나 보다. 아니면
Who don't speak.
Yeah.
And you know this episode. Who
I
don't
forgot.
speak and his wife wrote letters
I know, I
like that,
know.
and someone asked for the proposal, but that's not question. He can't understand. This guy is dry.
오.
Yeah, and also this guy, he like dancing. He
오.
wearing a high jump bag.
Pretty recently person.
Not recently, 32 is almost
I think
yeah. Ah, you
기원전.
배터리 충전은 안 되나?
really?
아예 조크. 한 1700 정도.
I understand. Chandrasekhar is in Indian.
Indian.
I mean, not Indian in America. Indian.
Indian.
Indoing.
아니 그 정도야.
It's Broi.
브로이?
Yeah.
브로이.
He Niels Bohr. You know the very.
오 예예. 닐스 보어.
You know the
He is a moon person.
moon. What is moon?
Moon.
You mean the big head?
No. Real moon. No?
What mean moon?
Moon person.
He discovered the moon.
Yeah. No?
No.
I'm sad.
Why? He. Big head. And sad. And low understanding. Niels Bohr and Einstein.
오.
1921.
Albert.
His picture.
Yeah.
Do you think Newton received this?
To it.
Yeah.
Newton? Newton so old
Yeah,
person.
Newton let die.
Yeah.
How about the Curie?
Curie
Marie
1800.
No, there's a Curie here.
Curie here.
Yeah. Maybe here. is
Curie
the
young.
Curie.
Marie
Curie,
Curie.
yeah.
Yeah.
The birth one X-ray.
I heard the story.
No, this already heard.
No. 마리 큐리 유품 오픈.
Why?
방사능,
Radioactive.
radioactive.
Yeah.
할머 어제 찜닭 남은 거 줄까요?
No, the 5 minutes. So let's read the chatting.
아들은 지금 이거 먹어봐.
제
먹겠다.
팬.
아, 괜찮편.
이거 먹어봐. 찜닭
음.
먹어.
배 안 고파.
Yeah. Sun is amazing.
3.
So, hoping a theoretical physics, classical physics, the world is never allowed an artificial. Yes. So the last year, AI received Nobel Physics Prize. So the people don't like that because that's not physics.
Yeah.
Do you think so? AI is the physics?
근데 자기 쌀
No,
주문했다 했어요.
쌀 밖에 와 있다.
아,
특별한 데 있다.
I don't like salt.
특별한.
So there's a many people from the other country. This is Saudi Arabia.
맞아줄까?
On here.
I think. Belgium.
India.
Where's India? many Japanese.
So cute.
Both principal on the density building, maybe astronomy.
For a minute.
What is DRC? Dominican Republic. Something.
Interesting.
So, do you think who received?
이거 줘?
Maybe.
나 물리학자를 모르는데.
I mean, just the top.
아인슈타인
Let it.
워크 again.
Alone, I am South Korea. No one's here. Why there's no others?
Because
Korean people.
명절.
명절, holiday.
Everybody is 송편.
하고
busy.
80 minutes. Too much link. Too much link.
Yeah.
Do you want typing something?
즐거운 명절 되세요.
But they are not holiday.
Talk at me.
How about
What happened? Your film.
this one?
What happened?
Originally there's problem.
Oh.
Nobel Physics Prize. So this is the last year one.
Välkommen till Kungliga Vetenskapsakademin och den här presskonferensen då vi ska presentera årets Nobelpris i fysik. Welcome to this press conference and the Royal Swedish Academy of Sciences, where we will present this year's Nobel Prize in Physics. We will keep to our tradition and begin the presentation in Swedish and then continue in English. And you're of course welcome to ask questions in either language later on. Jag heter Hans Ellegren och är ständig sekreterare här på Kungliga Vetenskapsakademin. Till höger om mig sitter professor Ellen Måns, ordförande i Nobelkommittén för fysik. Och till vänster sitter professor Anders Irbäck, ledamot av Nobelkommittén för fysik och expert inom ämnesområdet. My name is Hans Ellegren. I'm the Secretary General of the Royal Swedish Academy of Sciences. And to my right is Professor Ellen Måns, Chair of the Nobel Committee for Physics. And to my left is Professor Anders Irbäck, member of the Nobel Committee in Physics and expert in this field. Årets pris handlar om maskiner som lär sig. This year's prize is about machines that learn.
There is no Korean.
Kungliga Vetenskapsakademin har idag beslutat att utdela 2024 års Nobelpris i fysik till John Hopfield, Princeton University, USA, och Jeffrey Hinton, University of Toronto, Kanada, för grundläggande upptäckter och uppfinningar som möjliggör maskininlärning och artificiella neuronnätverk. The Royal Swedish Academy of Sciences has today decided to award the 2024 Nobel Prize in Physics to John Hopfield, Princeton University, USA, and Jeffrey Hinton, University of Toronto, Canada, for foundational discoveries and inventions that enable machine learning with artificial neural networks. Professor Ellen Måns will now give us a short summary of the prize. Please.
Thank you. Learning is a fascinating ability of the human brain. We can recognize images and speech and associate them with memories and past experiences. Billions of neurons wired together give us unique cognitive abilities. Artificial neural networks are inspired by this network of neurons in our brains. This year's laureates for the Nobel Prize in Physics, John Hopfield and Geoffrey Hinton, used fundamental concepts from statistical physics to design artificial neural networks that function as associative memories and find patterns in large data sets. These artificial neural networks have been used to advance research across physics topics as diverse as particle physics, material science, and astrophysics. They have also become part of our daily lives, for instance in facial recognition and language translation. The laureates' discoveries and inventions form the building blocks of machine learning that can aid humans in making faster and more reliable decisions, for instance, when diagnosing medical conditions. However, while machine learning has enormous benefits, its rapid development has also raised concerns about our future. Collectively, humans carry the responsibility for using this new technology in a safe and ethical way for the greatest benefit of humankind.
Thank you. Professor Ebeck, are you ready to give a more detailed presentation?
Thank you.
Please.
Not fun.
Yeah. So this year's Nobel Prize in Physics is about artificial neural networks. Today, we know that this is a powerful computational approach. This was not evident 50 years ago, but it was known that we mammals are very good at pattern recognition by some sort of computation in our brains. And this sparked an interest in understanding the collective properties of networks of simplified neurons connected by couplings with a strength that could become.
Bye-bye. I should be quiet.
No.
Because I need to cook it.
The youngest person to be awarded Nobel Physics Prize was arrived at the age of 24. What is my age? 26? No, 25. Same age.
Yeah, same.
So if I received in this year, then the same. But no.
You go to Swiss right now.
Right now?
Right now.
Now the 5,638 people watching this training, and the 400, now the 6,000, and another one. Yeah. Oh, there are the Korean people.
Oh.
Two Korean people.
역시 Korean, Korea.
Korea?
Because
From Korea.
overtime.
How they make the flag in here? I also want to make the flag. Is your flag?
맨 끝에
This one?
쭉 내려. 더.
Oh. This looks like the Japanese flag.
Yeah.
But no Korea.
Why? Sad.
Looks like they are busy. Maybe there is some. Oh,
What happened?
Guy. Why they sit down in here?
They talking.
Looking something. There's a thumbnail.
Yeah, exactly. So the first time.
And not this one for us. Watching from Germany, Lucia Brazil. And
The king of the basic science. Physics.
from India. World stay tuned. Do something. Go speak something. Oh yeah. Peace prize to the Donald Trump.
네,
Maybe tomorrow or
진지하게.
Thursday. But he want to receive it.
Oh, wow. Really?
Some sentence the Peace Prize has been awarded in the 118 times since 226 individuals have been awarded.
이제 more difficult. In
Oh, what happens in here? There's some fucking Korean in here.
Hey, his brain not.
Yeah,
You know what I'm saying?
yeah, I understand. The oldest person there is at 96. Yeah, there's many Indian people.
Yeah, so many people.
So,
So,
he's a John Biden,
John Body?
not John Biden.
Body?
One Japanese use hiragana.
Oh,
Konnichiwa.
what he say? Konnichiwa.
Nobel Prize for Photonics. I am a physicist for cosmos. I hope, but maybe not. The way I this time.
Yeah, I think so too.
If GPT received that, then what happened?
People aggressive.
Oh, you know the graphs.
Yeah.
Very difficult.
Ha 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 ha.
There's also the one more ugly Korean. Should I?
한마바퀴 후?
Should I
블록.
block?
블록.
Yeah,
근데 저 people who?
I know. Who is that?
Bad person?
Ugly
Ugly.
Korean. Many Indian people. Oh, Neutrino.
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 Yeah. Say hello.
This is something.
뭔가 한숨 쉬었는데.
Here?
Yeah. No?
Ah, no. 60 minutes.
Oh.
Why does some Korean use Korean? All use English here.
Because 저런 people 사회성에요. No social
Someone from Kazakhstan.
power. 근데 여기까지 찾아올 정도면 관심이 있어서 오는 거 아닌가?
Someone's.
시비 걸려고 오는 건가?
I'm not certain.
English is difficult.
Yeah. Someone came and some three people will sit down in this chair and table. Then it will start. No one came.
Every year, same place.
Maybe. Is this the palace?
Palace.
Yeah, king's house. Or just the institute. Royal means the king.
Yeah.
Royal Swadeshi
Academy.
Academy. 왕립학원. 4 minutes 42.
Full. Potato. Oh, Insta.
Yeah. Waiting for them.
Yeah.
Now wait.
It's 3 minutes.
Yeah. My program plans
Oh,
in DM.
fire.
Yeah.
American likes fire emoji.
What's that mean?
Like up. Boom up.
Universal up.
Yeah.
I see. Interesting. One is two in here.
Stories.
So,
Oh,
still doing it.
yeah. Now 2:30.
Are you excited or just boring?
Boring?
Yeah. Excited or boring?
Me?
Yeah. I'm slightly boring.
Yeah, me too.
If I said I'm slightly excited, then if I said I'm slightly excited, then you're also excited,
Yeah.
or still boring.
Prize, excited.
So if I say boring, you also say boring. I say excited, then you are boring.
No.
You are excited.
Yeah,
So
yeah.
you always borrow me?
No.
No? Yeah.
Was it like telepathy?
Someone likes to condense the math's physics and the proofs of the working surface area theorem. Or picture microgravity. Many people. Now the 1 minute 36, 35, 34.
34.
But still this is finished. Maybe it might not be stopped
Wait, why?
because they are late for
So late.
multiple Nobel Physics Prize. Fifteen, 7, 6, 5, 4.
Countdown.
49, 48, 47, 46, 43, 49, 47, no, 27, 26, 24,
10 seconds.
32, but still no one comes. 17, 16, 15, 14, 13, 12, 11, 6, 5, 4, 3, 2, 1. Now, live. Now start.
It's boring.
Always things like that. Not starting.
So, not promise. No.
Every say, let's go, here we go, come on. Come on. Here we go, let's go. Time to announce.
Everybody, hurry up.
Someone want to stop sending flag. And someone is good morning.
They morning now.
Yeah. No start.
Live.
Live. They said live, but
No live.
no one come.
Hey, sleepy.
So nothing. Oh yeah.
Hmm?
Now someone come.
Oh.
Now I will.
Yeah. Go.
Yeah. 1%. Doors open.
Big hammer.
Yeah. Full screen.
Yeah.
Yeah, I understand.
Yeah.
Maybe she's just officer,
Hmm.
not the professor. No, this guy is the same guy in last year. But these two guys are new. Yeah. Now they sit down. Maybe this is their name. Maybe their name. Right. Yeah. Right.
Välkomna till Kungliga Vetenskapsakademin och den här presskonferensen då vi ska presentera årets Nobelpris i fysik.
Yeah.
Welcome to the Royal Swedish Academy of Sciences and this press conference where we will present this year's Nobel Prize in Physics. We will keep to our tradition and start in Swedish and then continue the presentation in English. And you are of course welcome to ask questions later on in either language. Jag heter Hans Ellegren och är ständig sekreterare här på Kungliga Vetenskapsakademin. På min ena sida sitter professor Olle Eriksson, ordförande för Nobelkommittén i fysik. Och på andra sidan professor Göran Johansson, ledamot av Nobelkommittén för fysik och sakkunnig inom ämnet. My name is Hans Ellegren. I'm Secretary General of the Royal Swedish Academy of Sciences. To my right is Professor Olle Eriksson, Chair of the Nobel Committee for Physics. And to my left, Professor Göran Johansson, member of the Nobel Committee for Physics and one of the experts in this field. Årets pris handlar om att möta kvantmekaniken på ny skala. This year's prize is about encountering quantum mechanics on a new scale. Kungliga Vetenskapsakademin har idag beslutat att utdela 2025 års Nobelpris i fysik till John Clark, University of California at Berkeley, USA, Michel Devoré, Yale University och University of California at Santa Barbara, USA, och John Martinis, University of California, Santa Barbara, USA, för upptäckten av makroskopisk kvantmekanisk tunnling och energikvantisering i en elektrisk krets. The Royal Swedish Academy of Sciences has today decided to award the 2025 Nobel Prize in Physics to John Clark, University of California at Berkeley, USA, Michel Devoré, Yale University and University of California at Santa Barbara, USA, and John Martinis, University of California at Santa Barbara, USA, for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. Professor Eriksson will now give us a short summary of the prize. Please.
This year we celebrate the centennial anniversary of the discovery of quantum mechanics and the seminal publication of Werner von Heisenberg. This is a theory of the microcosmos, that of atoms and electrons, and there's no advanced technology used today that does not rely on quantum mechanics and quantum physics. Examples are easy to find in the room: mobile phones, computers, cameras, and the fiber optic cables that connect our world.
I think you can't listen.
Quantum mechanics stands on several pillars, most prominently the energy quantization and the quantum mechanical tunneling phenomenon.
Do you think just turn off?
This year's Nobel laureates have shown experimentally in studies published in the mid-1980s that quantum mechanical effects are found in new vistas outside of the realm of the microcosmos, hence embracing macroscopic objects.
Oh my.
So what is that?
Thank you, Olle.
Thank you.
And Professor Johansson, can you give us a more in-depth presentation of this year's prize?
Yes, thank you.
Ah, I understand.
Oh. Oh.
Quite complicated. I don't know why.
So, this year's prize is about quantum mechanical tunneling. This is a quantum mechanical effect that was discovered soon after Erwin Schrödinger published his famous wave equation in 1926, almost exactly 100 years ago. Soon after it was published, solutions were discovered where a particle could penetrate a classically impenetrable barrier. So to the left here, you see that exemplified by a wall, and the little boy throwing a classical ball onto the wall. It always bounces back.
The point is that
however, quantum mechanical particles can sometimes appear on the other side of this classically impenetrable wall, and it is as if it dug a small tunnel through the barrier. Hence the name.
But these three scientists,
soon after tunneling was discovered, it was also discovered that it's not only an astonishing theoretical prediction, it also has practical implications in the subatomic world.
Genius.
So to the left, you see a big nuclei, lots of protons and neutrons, and so-called alpha decay of this nuclei can be explained by the fact that the alpha particle, 2 neutrons and 2 protons, is bound, it's part and bound to the nucleus by a barrier. And classically, it would never ever leave the nucleus. However, due to quantum mechanical tunneling, it can appear outside of the nucleus, and thus you have radioactive decay. And the fact that it's quantum mechanical tells that it's a completely random process, and also by calculating the width and the height of the barrier, you can calculate the average waiting time for this decay or the half-life. So, we understand that quantum mechanical tunneling is important in the subatomic world. However, can we observe larger systems that tunnel?
This is still small size.
This was a question raised by Nobel laureate Anthony Leggett in 1978. He suggested that it should be possible to observe something called macroscopic quantum tunneling in a superconducting circuit.
Wow.
So how should we understand this? Well, in the upper picture here, you see a normal conductor. In the normal conductor, the electrons are very individual. They are fermions, and they are very easily distracted. So if you push a current through this conductor, the electrons are easily distracted, and there is resistance. Thus, you always get the voltage across this conductor. In the second picture, you see how a superconductor works. Here, the electrons take each other 2 and 2 by the hand, and then they are it's much harder to distract them. So then they can lead a current without any resistance at all, so there is current without any voltage. A supercurrent.
Current.
In the lower picture, you see another example. You see also an illustration of how this works. It's actually so that all of the Cooper pairs lose their individuality altogether, and they all condense into one macroscopic state. So it's one Cooper pair condensate, which is determined by one macroscopic wave function or a superconducting order parameter. And you see there is a small gap between the two conductors in the lower picture, and that's a so-called Josephson junction. So in 1962, Brian Josephson predicted that you can, even if there is a small weak link or a gap in the conductor, you can still have a supercurrent. And he derived simple equations for how the current and the voltage in this junction relates to the macroscopic wave function on the two sides of the weak link. And from his description, you can do the following. You can, if you push a current through the Josephson junction, it can then appear in two different states. One without the voltage and one with a measurable voltage. And the switching between the zero voltage state and the state with the voltage is, there is a barrier in between. And by detecting how this switching occurs between the zero voltage state to the voltage state, this is how our three laureates managed to prove that there is macroscopic quantum tunneling.
One more picture.
So, to the left you see an illustration of macroscopic quantum tunneling. So, our three laureates positioned, they push a current through the junction, and it was in a state so that it should not classically be able to switch. And yet it switches from the zero voltage state to the state with the voltage.
This is also temperature.
Although classically you see that it cannot switch.
Why they are
And if you're a physicist, you might realize that the smoking gun evidence for this macroscopic quantum tunneling are when the black dots here deviate from the diagonal line. That's where macroscopic quantum tunneling dominates. So the three laureates, so this breakthrough experiment was performed in 1985 at Berkeley, and the group leader John Clark had long experience of working with Josephson junctions. John Martinez was his senior PhD student at the time, and Michel Devoret was a postdoc coming from Saclay outside of Paris, with experience from low temperature physics, but not with Josephson junctions, molecular solids. So this trio did not only do this breakthrough experiment, they also did another breakthrough experiment the same year. So the name quantum physics comes from the fact that atoms absorb and emit energy in packages, so-called quanta. And by irradiating the Josephson junction with microwaves, they could verify that this macroscopic object absorbs energy in a quantized way. So there are quantized energy levels.
Yeah, so fast.
So, yes, I just want to mention also that in this system of the Josephson junction, there are billions of Cooper pairs. So it's really a macroscopic object in that sense.
Again say.
Okay, so this might sound a little bit abstract. However, this is a sketch of this experimental setup coming from John Martinez's PhD thesis. So you see the scale bar to the right, 1 centimeter, and there you see the silicon chip with superconducting wires, and the Josephson junction is exactly where the two wires meet. You apply the current to the left at the power connector, and then you measure the voltage at the same place. And when you radiate with microwaves, you do that in the microwave contact on top.
Too hard.
Yeah.
Then you also see there's a copper tubing and copper powder inside, and that's a newly developed filter for this experiment that isolates the Josephson junction extremely well from the environment, which you need because these quantum effects are very sensitive to interaction with the environment. And I think to make it even a little bit less abstract, I also want to show you a modern quantum chip
in the past.
So the silicon chip is the square in the middle here. There are superconductors on top.
Is that cotton?
And then there are 9 artificial atoms on this chip. And you can see them with your naked eye. So, the 3 laureates has established, so the picture illustrates how they have taken quantum tunneling and quantum physics from the subatomic world onto electric chip. So now we had 40 years of lots of groups in the world exploring quantum physics on a chip, engineering artificial atoms, exploring quantum physics in regimes which are hard to get to with natural atoms, because you can engineer these artificial atoms. You can also couple the superconducting atoms to mechanical oscillators, and then you probe quantum properties of mechanical oscillators. And you may also have heard that this is one of the platforms where you can develop a quantum computer.
Younger people can.
25, how received?
Maybe the.
Thank you, Göran. Do we have Professor Clark with us on the phone?
Yes, you do.
Good morning, Professor Clark, and congratulations to the Nobel Prize in Physics.
Thank you so much.
Was this a surprise to you?
So, to put it mildly, it was a surprise of my life. And I'm very sorry my 2 colleagues are not with us.
I'm sitting here in this beautiful session hall of the Royal Swedish Academy of Sciences at the press conference with many interested journalists here, both from the national and the international press. Are you ready to take some questions from them?
Yes.
SVT?
I have to congratulate you on the award, of course. My first thought was that it's quite mind-boggling, your discoveries. I was wondering